Good morning, guys. I just have a quick minute to make a video for your day today to go along with your lesson. We're going to be doing area of quadrilaterals, and a quadrilateral is just a four-sided shape. Okay, so you guys are used to four-sided shapes like squares, and you're used to having four-sided shapes that we call rectangles. And these are special types of quadrilaterals because they have four 90-degree angles. Okay, not all quadrilaterals have that. Quadrilateral just means four-sided shape, and it does not have to have a 90-degree angle at every corner in order to qualify as that. If you notice, if I pull this over here, that is still a quadrilateral, still has four sides. If I pull this corner over here, still a quadrilateral, still has four sides. But there's special kinds of quadrilaterals, and today we're going to be specifically talking about parallelograms and trapezoids. So let's refresh our memory on finding the area of a regular quadrilateral that we're familiar with, such as a square. In order to do this, you need the area formula. And the area formula for a square or a rectangle is just going to be area equals length times width. I want to start referring to the length and the width as base and height because that's going to be more helpful to you. So from now on, we're going to talk about the area as the base and the height. And what's important to remember with base and height is that whatever side is your base, your height always has to be perpendicular to that side. And perpendicular means a line that comes off at a T, at a 90-degree angle to the base. So if this is my base down here, my height has to come off at a 90-degree angle. And that little tiny square symbolizes that that angle is 90 degrees. If that square is not there, you cannot assume that it's 90 degrees. So let's take a look at the square. We have a side of 4 and another side length of 4. Actually, they're all 4 because they're squares. Well, in a square, all the corners are right angles. So no matter what side you choose to be your base, you just need a side perpendicular to that to be your height. So this one is my base. These two are perpendicular. See, they're both at right angles. So either one could be my height. Let's take a look at doing this with a rectangle. So with a rectangle, let's do a side measure of, let's see, 1, 2, 3, 4, 5, 6, 7. Oops. 7 for my side. Not one to right. There we go. And 4 on this other side. Okay. Well, if I choose for this to be my base, then I need a side that's perpendicular, which just means at a right angle, to be my height. Okay, so imagine that you're looking at this rectangle. Maybe this is a building, a house. The bottom is the base, and then how tall is that structure? That is your height. Okay, but I could just as easily choose this to be my base because if I were to turn this around, now that's my base, right? So you have to be flexible in your thinking. And just know that no matter what you choose to be your base, your height will be perpendicular to it. The first quadrilateral that you're going to encounter today is called a parallelogram. Parallelogram is very similar to a rectangle, except that it has no 90-degree angles. It still has parallel sides, just like a rectangle or a square. See, this side and this side go on. If they were to go on forever, they would never touch. That means they're parallel. And this side, if they were to go on forever, they would also never touch because they're parallel. But there's no right angles. Here's an obtuse angle, another obtuse, an acute angle, less than 90 degrees. So how do we find the area of this? Well, what if I were to take this little corner piece right here and put it over here? That exact shape, if I were to just move it over here, okay? If I were to do that, you can see that what I would end up with, okay, if I took that away from over here and added it over here, I end up with a rectangle. My parallelogram becomes a rectangle. I just took that corner that was here and added it over here. Well, it's the same area, right? It's the same amount of space. I just moved it to this edge, which means that whatever this area of my rectangle is, that's the area of my parallelogram. So can I do that? Can I just take the length and the width? How does that work on a parallelogram? It's the same way as with a rectangle, except you have to remember base times height. So here we have a base, 1, 2, 3, 4, 5, 6, 7, 8, 9. We have a base of 9. Okay. And then we have a height. But height means perpendicular to the base. And this side is not perpendicular to the base. So what we're going to do is we're going to extend out this base in our thinking. We're not actually going to take a new measurement. We're just going to extend it in our thinking so that we can come off of that base and get a perpendicular line that is our height measurement. So the height here from the very bottom to the very top is 1, 2, 3, 4. And 9 times 4 is 36. So base times our height of 4 is 36. And whatever the units are, it would be squared units. So if this was inches and inches, this would be inches squared. Okay. All right, let's talk about a trapezoid. Trapezoid is very similar. It has one set of parallel sides, but the other set of sides is not parallel. You can see that these two lines, if I were to extend them out, they'd go on forever, but these two lines, they would eventually touch. Okay, if I were to extend these lines out, they would eventually intersect. Okay, they would eventually cross, and they would trap whatever's inside. So I like to think of them as a trapezoid because as those lines extend out, they're going to trap whatever is behind them. So how do we figure out the area of a trapezoid? Well, it's still a quadrilateral. So we need to be thinking about base and height, but there's a couple of strategies here. One strategy would be to decompose this into shapes that you're familiar with. So here's two triangles and a rectangle. So we could take the area of this triangle, which is a base of 2, a height of 4. We could take this triangle over here, which is a base of 4, also a height of 4. And then we could take the center rectangle, which is 1, 2, 3, 4, 5, 6, and a height of 4. You could take all three of those individual shapes, add them together, and get your area. Remember that the formula for triangles is base times height, but then you cut it in half. So you would do that. You'd get 16 divided by 2 is 8 for this shape right here. And then over here you would get 2 times 4 divided by 2. 2 times 4 is 8, divided by 2 is 4. That'd be your area here. And then 6 times 4, 24. Don't cut that one in half because it's a rectangle. So you would have 4 plus 24 plus 8. All right, that all together would be your area. But there's another way to do this. Let me erase what we've got. We can cut it into a different shape. What if we take this trapezoid and we were to cut it? I'm just going to copy this over here. What if we were to cut it this way? Now we have two triangles. We can do the area of two triangles, right? We can take the base measurement. We can pretend that this triangle is upside down and extend this base right here, measurement 1, 2, 3, 4, 5, 6. And then the height of it, we would have to come off at a perpendicular angle, which we don't have. So we're going to have to extend this over here in order to get this perpendicular side, which is 1, 2, 3, 4. Okay, so 6 times 4. And then cut that in half. So 6 times 4 is 24. Cut it in half is 12. And then you have this triangle here with a base of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and a height of 1, 2, 3, 4. Again, has to be a right angle, can't be this side measurement over here. You have to imagine a line that's coming off of this at a right angle, and that has a measurement of 4, a height of 4. Okay, so that height of 4 times 12, that's 48. But if we cut that in half, you get 24. Okay, so then you would add both of these two pieces together, 12 and 24. Okay, that's going to be 36. So those are two ways to get the area of a trapezoid.